guys, welcome back to the last golf video. Well, today I'm going to be talking about the Arduino Uno and basically how to build one. Now, why would you want to build one of these? Well, the Arduino Uno is really great for projects, really rapid prototyping. You got nice little pin set here. It's really nice. You got FTDI breakout to serial, this and that, USB, really easy to program, and it's really great for projects. Now, basically, what is an Arduino really? Well, basically, it's one of these. If you look right here, there is a little ATMega microcontroller. And basically, the microcontroller is the thing that is running the code. Here's a different one. And all these little connections here are going out to these pins. It's going out to the USB, power, this and that. So basically, it's just one of these. It's basically just a microcontroller built out, so it's just really easy to program. Now, here's the thing about these. The problem is they're $35, and if you want to put them in a project, it's really not like, it's not easy. And plus they're really big, so if you want to like put it into a project box, you really can't. So I'm going to show you how to take one of these. I'm going to make it so you can actually build one of these Arduinos and put it into one of these. Now what is this? Now this is an ATMega328P-PU. You want to make sure that you get this type of microcontroller and not the the ATMega328, because there is a difference and it won't work. So basically what you're going to need for this project here, you're going to want an Arduino Uno. And, well, actually as the ISP programmer, and once we're done programming it, we could just put this away, build an external power supply, and put it on one of these. And I'll show you how to do all that. You're going to want an Arduino Uno, your ATMEL microcontroller, a 16 megahertz Resonator. Mine looks a little different. The Resonator on the actual Arduino is right here. It's kind of like a little thing here, and I might put a link in the description for that, so look out for that. The Resonator, also known as a crystal oscillator, so if you kind of want to Google that on Amazon, you can pretty much find them everywhere. Mine, this little third prong here is actually not part of it. It's just, I got the thing, it decided to have a little solder jump, I don't know. But they usually only have 2 pins. Make sure you get them with 2 pins, not 3. Mine, again, has a third one because that's just grounded to the shell. That doesn't actually do anything. Alright, so you're going to want one of those. You're going to need 2 22 picofarad ceramic disc capacitors here. Make sure you get 22 picofarad, or else it really won't work. I mean, it kind of works, but you want to make sure you have capacitors. 2 electrolytic polarized capacitors. Here I have 3.3 microfarads at 350 volt. And let's see, you're also going to need a 5 volt regulator. Now mine I bought at Radio Shack. This one is the LM7805C. You're also going to need a small flathead screwdriver. It's not really necessary, but it makes things a lot easier. You're obviously going to want a breadboard or some kind of soldering board. You can solder it to it. And you might want a resistor for an LED. And you're going to want a ton of wires. Oh, shoot. Going to want tons of wires here. You're going to want a battery clip. You want a 9-volt battery clip. Mine has just 2 little connections. Now you could just make one with alligator clips, but mine just makes it a lot easier. At the top here. And you're also, of course, going to want a 9-volt battery. Here I got mine at Family Dollar. They're like about $1, so really good price. So what we're going to do, I'm just going to take all this. Now for now, I'm just going to be using the Arduino as a power source. So I'm really not going to need this 9-volt thing, and these are going to come later and stuff. We're actually going to build an external power supply for it, so we can really power it by itself. So here's what we're going to do here. I'm going to try to do this the best way I can. Now, if you look at the controller, there is a tiny little nub at the top here. Let's see if I can see that. There's a tiny little nub right about, let's think of my thing here, right here. I don't know if you can see that. There we go. Right there. So I kind of have autofocus turned off, but it's right there. Now, you'll notice that there isn't one on the end. Now, this is very important that you lay this out correctly, because if not, all of your connections will be wrong. So I'm going to place mine, if you want to follow along, I'm going to place mine with the nub here. Now, one thing I forgot to mention here is that this chip right here I actually purchased with the Arduino Uno bootloader on it. Now, basically what a bootloader does is it allows the Arduino to basically communicate with this thing, basically program it, this and that. So I would recommend getting one with it because it makes things so much easier rather than trying to go in and programming it all yourself. I mean, it's just a hassle. So I would just recommend just buying one straight on. And when you do, you're going to have to bend each one of these pins. I recommend a pair of pliers to do this so it'll fit into the breadboard. Now, if you look at mine, you'll see that the pins are actually not on the same rail. This is because a breadboard, the way it works, each one of these lines here is one connection. So I could take one wire, I could plug it in here, and another one here, here. Now these wires are connected. So to give you, actually they're not, yeah. So to give you guys kind of idea on how this works, that's how breadboards work. So the bad thing is, if we were to put our microcontroller over here into just one half of this, that would basically create a short between these two pins. And we don't want that. We want each individual pin to have their own line. So basically, people who make breadboards, whatever, they put what's called like a dip socket basically in the middle of it, and you place your microcontroller in between this, and it provides an individual socket for each one of your pins. Now, so here we go. So what we're going to do is we're going to take, well, first we need power. So how are we going to do this? We're going to take 5 volts on the 5-volt pin of the Arduino, and we're going to count to 7 here. So here we go. We have 1, 2, 3, 4, 5, 6, 7. Now this is VCC of the microcontroller, and I'm actually going to put up a little picture of this because I think it's just a lot easier. So let me get a picture up here. Now this actually, you'll notice this is from the Arduino website, and basically what this says is, this is the ATMega328, but that's fine because the 168 and the 328 actually have the same pinouts, so that's fine. They just have a little bit, but do not try to use this process with an ATMega168. I've tried, doesn't work. I still haven't figured out a way to do that, but I might. So next up we're going to do is obviously go to ground to ground. And actually what I'm going to do is I'm actually going to set up a 5-volt line, because later on we might connect other things like this here HC05 Bluetooth module, which is really fun to play with. So we're going to connect 5-volt to the plus line of this, and the ground to ground. And what does ground mean? Well, ground is basically just the negative terminal. Alright, so let's see here. Let me just make sure that goes in there. Okay. So now what we're actually going to do is now hook up the 5-volt line to 5 volts. So we have 5, and now we go 1, 2, 3, 4, 5, 6, 7 VCC. And now we get ground to ground. Now I'm just using random colors, guys, because I really don't want to go through, but you kind of want to basically keep it like this here. Okay, so now the chip is getting power. Let me move this out of the way so you guys can kind of see that a little better. Okay, so what we're going to do now is, in order for this to work, we have to put in a 16 megahertz external resonator. Now, this chip by itself does have an 8 megahertz internal resonator, but for some reason you can actually configure it to work with the Arduino, but in my case, I think it just is a lot easier just to use a 16 megahertz resonator. Now the crystal pins, if you'll look up here, it says the crystal pins are beneath ground. So we're going to connect our 2 pins of the resonator, and we're going to connect crystal and crystal. Polarity does not matter. So I'm just going to plug this in. Now mine are a little stiff to put in because I accidentally screwed up from another board and had to solder back in. Okay, alright, that's matter. Next thing we're going to take is our 22 picofarad ceramic disc capacitors. Or I guess ceramic capacitors, aren't really disc capacitors. Maybe they are, I don't know. And we're going to connect in parallel both of these sides. Let me see if I can get a little better picture of this. One here to ground. Oh my gosh. Shoot, I got it stuck. Okay. One side to crystal. Wire this in parallel to ground. Now let me get a better picture of this here. Okay. Kind of see a little better. Okay. We're going to take the other one and do the same thing on the other side. I'm going to move this pin out. Okay. And I'm going to take the other side of this here crystal. I'll plug it straight into ground. This is called a parallel circuit, in case you were wondering. I might use my pliers because these wires are very bendy. Okay. There we go. It is now ground. Okay. So now we have 16 megahertz resonator and we have power to it. Okay. Well, how do we program this? Well, let's take a look here. I'm just going to move this up so you guys can see this a little better. So let's take a look at our pinouts here. If we look, we have on the pins, we have on pin 19, on pins 16 through 19, we actually have a thing, we have SS, MOSI, and MISO, and SCK. Now, what are these pins? Okay, so MISO, and then MOSI, which is master out, slave in, and these we don't really need to worry about. So, what are we going to do here? Well, what we're going to do is actually, before we even do anything, we actually need to configure our Arduino run as an ISP. Now, what is an ISP? An ISP is an in-system programmer. And, well, why do we need this? Well, basically we need a way to program our new chip. So how do we do this? Well, we have to get this to act as an ISP, and to get this to do this, we have to load up the Arduino software. Now, this is where it gets a little tricky, because this is where I screwed up. This can be very tricky. So if you don't get this, you will most likely not get this your first try, because it is just very difficult in general. So basically, what we're gonna do. Okay, so the first thing we're gonna want to do is we're gonna actually just flat out upload this like normal. So basically, what I'm gonna do is I'm gonna connect in on my Arduino, my regular Arduino. I'm gonna set this to Arduino Uno board. Now let me get this up here. I'm gonna plug this into my computer. I have power now. Now on my board here, I'm gonna select board. I'm gonna select Arduino Uno and comp3. Yep. Okay, we're good to go. Okay, so all this stuff is just really impressive. But all you're gonna want to do, you're gonna click that upload button. And if you take a look at my Arduino here, let me see if you can see that a little better. You'll see that it's starting to beep. Compiling sketch. And for some reason, make sure you're not listening to music while you do this. I found that really messes it up. So you'll notice that actually, this light here, I'm just going to show you this for now. This light right here, oh, it's going to lag horribly. This light right here is lighting up. Now, this is because for some reason it's telling us that we have a good connection, which we really don't. Now, if this light doesn't light up for you, don't really worry. I mean, it's supposed to act as an ISP, so that's what an ISP usually does. If you have a good connection, it'll show you that you have a good connection. Now, you'll see that we have reset pin right here. Reset goes to digital pin 10 of the Arduino. This right here, we're going to connect in, we're going to count over 2 pins. And the third pin from the bottom, we're going to connect to pin 11 of the Arduino. Okay. The next pin we're going to do is the one next to that one. There it is, I'm falling out of the screen here. We're going to go to 12, digital pin 12 of the Arduino. And the next one we're going to do is the one next to it, and we're going to connect that one to pin 13. So what should you have here are 3 pins right here, connecting here, and 4 connections here, 10 being to reset. Okay, so that's all good and fine. Now we want to know if this thing is really programming. Now this isn't actually essential, but I want to have it because it makes things a little easier to see what's going on. I'm going to connect a resistor. I'm going to use any resistor. I'm going to connect it to this last pin here in parallel. So right here, if you can kind of see that. Let me see if I can move those wires out of the way. You'll see that this red wire and this resistor are actually in the same spot. And you're going to connect this LED, I'm going to connect the positive of it to the resistor line. Oh shoot, make sure this is not shorting out to any other Arduino pin or microcontroller pin. I'm going to connect the positive terminal to the resistor. I'm going to run a wire from the negative of that into ground. Okay. Now, what we're going to do, now this right here, my light isn't lighting up. Now, I don't know if sometimes it's good, sometimes it's bad. So basically, sometimes for me, the LEDs was actually screwing it up. So sometimes I take that off. But you don't need to. I mean, I think it doesn't really matter anyway. I actually might take this off because I think that does actually kind of screw with it sometimes. No, you know what? I'm going to leave it back in. I like that. I like it there. Okay, anything I'm forgetting? No. Okay, so now comes the tricky part. We have to go back to our blink sketch. We need to go, now I am running on Arduino 1.0, oh you can't see this, but I'm running on Arduino 1.0.5-R2. And here's the reason why. This old software has all of the boards. I mean, you get tons of boards here. On the newer software, you don't really have that option. So it's pretty critical that you have the old software. I'd actually recommend downgrading. There's a lot more options. I think it's just better in general. So I'd recommend doing that. So if we take a look here, just really quick, the LED pin is actually pin 13, and if we go back to our pin mapping here of the ATMega328, we'll see that pin 13 is actually right here, the LED connection that we just made. So that's all good and done, just for fun. So this thing will actually flash really heavily, but this is where we get to the part where it's really complicated. What you have to do, go to Tools. Basically what you have to do is you have to make it so, sounds like we've already uploaded the ISP. We need to select Do Milanov with, I don't even know what that's called. Oh, you can't see this. That's really bad. Okay, well right now it says you're going to go down and it's going to say Arduino Do Milanov with Arduino 328. You want that one. Alright. So, let's see, will it show me? Yeah, we can see that at the bottom of my screen. It says Arduino Do Milanov with 18, these names. Right down here you'll see that. Arduino Do Milanov with ATMega328 at COM3. Make sure you select whatever COM port you're using. Mine's using COM3, so I'm just going to use COM3. Make sure serial monitor isn't enabled. And for some reason, like I said, don't listen to music. I don't know why. It doesn't work. Okay. Programmer. You want to select Arduino as ISP. Make sure this is make sure you're using this. If you're not going to use the Arduino as an ISP, there's a bunch of other stuff you can use. You can use a USB Tiny ISP, Parallel Programmer. There's a bunch of options. The problem is with some of these, like the Parallel Programmer, it actually requires a parallel port in your computer. I actually have a computer that still has that probably, but you know, if this doesn't work out for you, I would recommend probably getting a USB Tiny ISP because I think it works. And that's like the best one, most stable one that's out there right now, something like that. So yeah, go with that, or I guess this one, something like that. Okay. Now, if you don't have a pre-bootloaded one, you want to use the burn bootloader command. But since I already have it on there, I'm not going to use that. Now, this is critical. Make sure you upload it using Programmer. And I'm going to do that. And if you get an error message, don't worry about it. If you get an error message, let's see if I do. I probably will, because this usually doesn't really work on its first try. Let's see if it works. Okay, we're working. Oh, it does work. Okay. Now here's why. Here's how you'll know this is working. Well, for one thing, this will be blinking. And the second thing is, if you noticed, these lights here were flashing like crazy. That means it's good. Let me try to show you some other common messages. Some messages that you might get down here in this little error message here. You might get something like not in sync. That means probably one of two things. If it's not in sync, it's probably not connected, or you don't have the right board configured. So the easy fix for this, if that happens, check your connections, and go to board, and there's another one called Arduino Nano with ATMega328, that also works. So try that too. If that doesn't work, then you might have something wrong, totally wrong. So yeah, so basically guys, this is how you make a program. This is how you make an Arduino. We have a fully functional Arduino thing right here. Now, some things to mention. On the Arduino site, the Arduino to Breadboard says there are these pins. If you look at my pin mapping here, it says AVCC and ground on the right side of the board. I tried connecting those, and I don't think it really works. Although Atmel says you should, I don't think it's really working. I think it creates some kind of short to this, so I don't really connect them up. It just works flat out if you just use the VCC and ground. Another thing to notice, if you start getting error messages, try connecting this VCC pin, this VCC, to a VCC. That also kind of works for me too sometimes. Just another fun fact right here. Right here, we have some pins. Basically, these are actually the ISCP pins. You can actually use these to program this rather than using these. I think you can anyway. This I think works the best because I think it's most stable. Now let's look at some pros and cons of this method. The problem here is that this I don't think can have a ton of power. Plus you have to have an alternative power supply, which is also a bit of a downside. Whereas this just has, you just plug it into a wall or something with this DC jack, or plugging it straight into USB. Totally works fine. The TX and RX lines are sometimes a little weird. So this Arduino is very stable. I would probably use it in any case you can. This is a great prototyping board. But when you really want to make a nice circuit, I would recommend using one of these because they're just really small. You can fit them into compact areas, and it's Arduino basically as an Arduino. So Another thing to notice, now you could probably also switch out this chip here, and you could probably use it with some kind of AT Tiny 8 or 16, and basically what that is, it's one of these, but much smaller and a lot less capability, but they're really small. So if you only need to do a blink sketch, right, you would probably use one of those. Like, this is a bit of an overkill, because there's so many analog and digital pins. So I wouldn't recommend doing this, but, you know, this is good. Okay, so the next thing we're going to talk about in this next segment. So now that we have this finished, we can actually unplug these. We don't need programming pins anymore, because this is already self-working by itself. So we can just rip up all these. We don't need these anymore. We can actually get rid of the Arduino board for now. Okay. I'm going to get rid of this. Oh, things falling off my desk here. Okay. Let's move our new board here. So we have an Arduino working here, but here's the problem. We don't have a way to power it. Now, a nice little way of powering it would be a nice 9-volt, wouldn't it? And they're pretty small, pretty compact. They're pretty great, but here's the problem. This is 9 volts, and if I attach this right now, I will fry my microcontroller, because this only operates on 5, and unlike the Arduino here, there is no overvoltage protection. So if you apply way more volts than needed, you will kill the board. And these are about $6 a piece, so be careful of that. So we need to get 5 volts out of this 9 volt. Now, well, how do we do this? Well, here's what we have to do. We got to take one of these, a linear voltage regulator. Now, mine is an LM7805, like I said before. And the pins here, for this particular one here, we have input, ground, and output. Now you may be thinking, okay, why is there only one ground? Well, because both these grounds connect in together. But this will actually not work by itself. You have to have electrolytic capacitors. Now I just kind of picked up some random ones. This will get me about 4.9 volts, which works fine with this, so that's good to go. Okay, but how do we make this 5 volts? Now, here's the other thing you could also consider. You don't have to use any of this stuff. You could just take some AA's, here, and just string 5 volts together, and it's done. But I don't have those, and I don't have a battery clip for that because I'm lazy. So I'm going to use this 9 volt. I'm going to show you how to use this. Okay, so you're going to take your 5 volt regulator, and you're going to plug it in like such. Now make sure you're not plugged in like this, because this will create a short between all the pins, and this won't work. So you want to make sure you have it plugged in each individual pin. Okay, just like that. That might be a little tough because it's a MOSFET and it's kind of stuck in there. Just a little fun fact, MOSFET stands for metal oxide semiconductor field effect transistor, which is kind of fun. Okay, so the next thing you're going to want to do, you want to take your electrolytic capacitor. Now, what is an electrolytic capacitor? It's a pretty big word. Okay. Basically, an electrolytic polarized capacitor is a capacitor that discharges basically in a linear manner. So basically it's a battery, except instead of discharging like, how do I explain it? Maybe I draw this. Let me see, where's my pencil? Okay, so a capacitor, a battery, basically operates something like this, right? So it'll kind of go, and then it'll just drop when it dies. Capacitor drops in a linear manner. So we kind of get less and less volts as we go through time. So this is why we don't use a battery and we use a capacitor. So basically a polarized capacitor basically means it has a positive side and a negative side. And the way we determine this is this white stripe here. Now these capacitors over here have no polarity, so they just discharge and whatever. There's actually a pretty interesting video by Ludic Science if you want to check him out. It's pretty good. It's about capacitors. Is it Ludic Science or some other one? I'll put a link in the description. So, what we're going to do, I'm going to take my roly-poly capacitor. No, I'm going to take my 9-volt battery clip, and I'm going to plug in the positive side to V in, which is this pin here. It's the far left pin. I'm going to show you that. Okay, I'll take ground of it and plug it into ground. Okay, so basically that's pretty much it. So now all we have to do is take our 5-volt line that we were using from the Arduino side, and here it is, 5 volt, and we're going to plug it in to V out, which is the far right pin, and we're going to take ground and we're going to plug it in to ground. So now all we have to do is simply plug it in and there you go. And I just realized, how is that working? Oh my god. I didn't even use the capacitors and it's working. Oh my god, how many volts are we getting out of this? Let's test voltage. Let's see how this is working. Hope I'm not giving it too much voltage. Yeah, I'm gonna unplug that because in case I did, it's gonna kill it. So I'm not gonna do that. Well, how do we check this? This is pretty shocking. I never know I could do this. Let's look at this. Yeah, I know. Let's blow on battery. All right, let's probe this. So we're getting. Oh shoot, we're getting. Let's see. I think the ground is also here. So. Wow, we're getting 4.9 volts. That's awesome, dude. Look at that. 4.9 volts. Wow. Alright, well, you don't even need the capacitors. Okay. Actually, I'm going to plug them in just for safety reasons. Because, actually, yeah, you do need the capacitors. Here's why. Okay. Let's say you have some kind of imperfection in your circuit. I'm going to unplug this. And you get some kind of weird overcharge, and it sends it through this. It could potentially send more voltage than needed and kill your board. Now here's the thing: if you go above a volt, you know, maybe you go like 6 volts, 6.5 volts. It's a little risky, but the board should still work and not kill itself. I've done that, and it works totally fine. So you don't have to stress about that if it doesn't work. So I'm actually gonna plug in the capacitors just because I don't want to fry it. And the way we do this, we take the ground side, the negative side of the capacitor, and we plug it into ground. And with the positive one going to the far left pin, we take the other capacitor, we take the negative side, we plug the positive side to the far right of the MOSFET, and the left back into ground. So both capacitors should be wired in parallel to the ground of the MOSFET. Now we hook back in our power. V in. Oh, it's going to be a tight fit. And this is really hard to see, but I'll try to show you this in a second. And the V out back into ground of the MOSFET. So that is good. So let me just kind of show you this 5-volt regulation system I have here. We have our two capacitors, ground to ground and ground to ground. This is really hard to see, I know. And basically, I have autofocus turned off, so that's why it's a little hard to see. But that's basically what you have to do, and it's really hard to see. Or you don't use the capacitors at all and use like the way I showed you with no overvoltage protection. This kind of provides a bit of it. It takes in basically, I think it'll take any kind of impurity and pump it out 5 volts, kind of stabilize it. Because remember, this dart discharges linearly. So that is it, guys. If you want to reprogram this, all you got to do. Take your Arduino. You could use this external power supply, plug in these pins back into here, and just program it. So that's pretty much it, guys. That is how to build an Arduino and how to program it. So really, if you really want to just use this as your circuit, all you gotta do is use just very few amount of components rather than just shove this whole thing into a box. Because this will probably fit on a board about like that big. So that's really great. So thank you guys so much for watching. It's been really fun making this video. I hope you got something out of this. I know a lot of people on the internet have been having some trouble doing the 328 programming with an Arduino Uno. So I just kind of want to show you guys how to do this. Please drop a like, share, and subscribe.